We also have this important corollary of the side splitter theorem. So let's have a look. So we can extend that idea. Same thing that happens in a triangle happens with parallel lines cutting two transversals. The segments that are determined on each one of the transversals, they are proportional to the segments on the other transversal. So in this case, the segment AB is to BC as DE is to EF. So this is an important result for us to keep in mind. Apart from this, we can use our theorem, our side splitter theorem, to establish a theorem about the bisector of one triangle. So we'll try this next. It's called the triangle angle bisector theorem. So you have a triangle. You have a triangle such as this one right here, UVW, and you have a bisector. Remember, a bisector of an angle is a ray that divides that angle into two congruent angles. In this case, UVX and XVW. Those two angles are congruent. And that bisector determines on this side that it intersects two segments, UX and XW. And each one of those, like UX, is to WX as UV is to VW. So these two segments that are determined by the bisector are proportional to the corresponding sides of the triangle. And that is something that we can apply to answer questions such as those given in example 5. So knowing that this BD bisects angle B, we can tell that because these two angles are labeled the same way. We know that the two segments formed, CD and DA, are proportional to the corresponding sides CB and AB. Please notice here the order is important. So when you're trying to establish the proportion, you're gonna do AD is to CD as the side that is on, if you think of this as a line for a second, there are two segments, DA and AB. Those two are on the same side of that line, and CD and BC are on the other side of that line. So you want to always establish the proportion by keeping in mind the two segments that are on the same side. So in this case, I'm saying AD is to CD, and now we're gonna put at the bottom AB, which is the one right here, AD, CD, and then the side that is with AD is AB. Those are the two segments that are on the same side of the bisector, and CD and CB are the two segments that are on the other side of that bisector. So let's say that those two are at the bottom, and then AD and AB are at the top. So after that, you just replace the information. X over 13 minus x equals 10 over 16. You will cross multiply it here to get the equivalent equation, and that leads us to x equals 5. So because x equals 5, then we can find AD is going to be 5, And of course, CD will be 13 minus 5, which is going to be 8. So we can find both lengths of those two sides, of those two segments in the determined on the segment AC. So just try to keep that in mind and see if you can answer the following two questions. As always, pause the video, and after you get an answer, please see if that compares, how that compares to your to the correct answer. In this case, the value of x equals 9, and for the next one, please be prepared with questions if you didn't get to the answer.